Today we are going to evaluate this limit of tan theta minus sine theta over secant square theta when theta is approaching pi by 2. So if you firstly we need to we will try putting this value of theta in this expression, and we will see that whether we can get a value out of it or not. So when we put theta is equal to pi by 2 in this expression, in the numerator you have tan theta, so you have to put theta is equal to pi by 2 there to check. So when we put theta is equal to pi by 2 there, tan theta is equal to sine theta over cos theta, and when you put theta is equal to pi by 2 in sine theta over cos theta, you get sine pi by 2 over cos pi by 2. So sine pi by 2 is just 1 and cos pi by 2 is 0. So we have a problem there, that we get a 0 in the denominator, and division by 0 is not defined in mathematics. And why is it not defined? It is not defined because it makes no sense. Normally when you divide a thing, you know that how many parts are you dividing it into, and division makes things smaller. Here you are dividing 1 by 0. What does it mean? That you are not dividing it? Because you must know that how many parts are you dividing that one thing into. It can't be 0. It's not. If it is by 0, it's not division then. So this is undefined, and we have secant square theta in the denominator. So secant square theta, secant is basically the reciprocal of cos theta. So secant is the reciprocal of cos theta, and secant square is 1 over cos square theta. So you run into the same problem. You get cos theta in the denominator, and when you put theta is equal to pi by 2, you get cos pi by 2 whole squared, and cos pi by 2 is simply 0. So we get 0 in the denominator again. So this is the problem, that you can't use this approach while evaluating this limit. This approach helps you when you are dealing with continuous functions, because the limit at a particular value is equal to the value of the function at that point. Here the function which we have been given involves two functions which are discontinuous at that which are not defined at that value, theta is equal to pi by 2. They don't give you a defined value. They become undefined at this value. So we have to think of some other way to evaluate this limit. Second thing which we can try is that we can think of this as in terms of the definition of limit. The definition of limit is when theta, or when the variable approaches some value, what does the given function what value does the given function approach? So here theta is approaching pi by 2, and pi by 2, theta is basically angle, and it is in radians. So when it is approaching pi by 2, what does our given function approach? So if you think of the numerator, tan theta has cos theta in the denominator, and theta is approaching pi by 2. That means cos will be approaching 0. It would not be equal to 0, it will be approaching 0. And when you divide 1 by a very small number, or by a number which is approaching 0, you get a very large positive number, meaning it is approaching infinity. We say that a very large positive number, when we are approaching a very large positive number, we say that it is infinity. So tan theta becomes infinity, and sine theta is just 1 for pi by 2. So infinity minus we are talking in terms of approaching pi by 2. So sine theta approaches 1 when theta approaches pi by 2. So infinity minus 1 over infinity. Infinity minus 1 is just infinity, and in the denominator we have infinity, so we get infinity over infinity. So we must now think of a way to get rid of this infinity by infinity form. And how do we do that? By manipulating our given function. So if you see the numerator, you see that tan theta can also be written as sine theta over cos theta. It can be written in terms of sine theta, and the second term is already sine theta. So you can take sine theta common from the numerator. So it can be written as sine theta. We are taking sine theta common, so it becomes sine theta into 1 over cos theta minus 1. And in the denominator we have secant square theta. So the problem lies with this cos theta in the denominator, because that is basically the thing which is stopping us from evaluating this limit by simply putting theta is equal to pi by 2. So we need to get rid of this cos theta in the this cos theta present in the denominators of both the fractions, either the fraction present in the numerator or the denominator. Both have cos theta in the denominator, so this is the problem. So when we take the LCM in the numerator, we get sine theta into 1 minus cos theta over cos theta, and the denominator secant square theta can be written as 1 over cos square theta. So the cos theta in the fraction in the numerator can be cancelled by the cos theta of the fraction in the denominator. So they cancel out, and we are left with sine theta into 1 minus cos theta over 1 over cos theta. So when sine theta into 1 minus cos theta is multiplied by this 1 over cos theta, this gets inverted. This 1 over cos theta becomes cos theta over 1. So now we can see that we don't have any denominators. We are left with sine theta into 1 minus cos theta into cos theta. So we can simply put this value theta is equal to pi by 2 to evaluate our limit. So when we put theta is equal to pi by 2, we get sine pi by 2 into cos pi by 2 into 1 minus cos pi by 2. So this becomes sine 90 or pi by 2 in terms of degrees is 90, but here it is pi by 2. So sine pi by 2 is 1, cos pi by 2 is 0, and it is being multiplied by 1 minus 0. So 1 minus 0 is 1, and 1 into 0 into 1 is simply 0. So the limit is 0.